So let's indulge in a little bit of networking today. One of AWS networking services, VPC. Well, that's a great introduction. Okay, so Amazon VPC, which is Virtual Private Cloud. As you can see here, this is the icon for it. So it's one of AWS networking services. And let's see what we have. So kind of a lot. We have like a lot of stuff today to talk about, but it's kind of interesting. So if you're into it, buckle up and let's get to this journey ready. So first thing we're going to talk about, of course, like always, we're going to give like a brief introduction on some of the key features of that service. We're also going to give a little bit of components, and in those components, there are going to be subnets, internet gateways, and bastion hosts, sorry, NAT gateways and instances. And those are components of VPC and a lot more. We're going to deep dive in them and like look into the details of it. Then we're going to talk a little bit of the use cases and best practices. So of course, before we go in, I want to do a quick recap, like always. So the cloud, of course, as we know, like Cloud 101, let's say, so C101. So as we know, cloud is what we call multi-tenancy. Okay, multi-tenancy. We agree on this? We agree. So let's say AWS, this is AWS infrastructure. So this is, I think I have AWS logo right here. Yeah, because I use it a lot. Okay, so let's go and look at the AWS logo. Oh, that's good. So I'm going to use this one. So this is the AWS infrastructure. And the way they part the cloud, it's what called its tenancy. So this is for customer 1, and this is for customer 2, and this is for customer 3 and 4. So C4, not the explosive C4, sir. C3, customer 3 and customer 4. Of course, this is AWS, and every customer has its own isolated AWS cloud that is separated from each other customer. So, why do we need VPC? What is a VPC? And the components. Of course, the components, we're going to talk about them later on, but let's get to the main point. So, this is AWS based on the infrastructure we have wrote. So this is AWS, and you want to separate your work from AWS cloud. So you're going to have what's called a simplified VPC. So let me have the icon of a VPC. It's here, somewhere here it is. That's huge. I don't need this. So inside of a VPC, you can also subdivide your network into what it's called subnets. You remember in networking, when we took networking, we've talked about the network and how we can subdivide the network. So we don't want like 16,000 users in one network. It's going to be complicated. It's going to be less security. It's harder to manage. So we don't need just one network with 16,000 users. No. We want like 10 subnets, and every subnet has a 200 user. So you can see the difference. 10 subnets, 200 users, or like less, like 20 users, let's say. And you can see the difference between one network that has 16,000. So of course, the one or the network that is 16,000 is harder to manage, less in security. And if it get breached or a hacker get in, ودعنا معلم سلام. There is no way of going back, خلاص. If he got in, it's no way out. Okay, so as we said, if we want to also subdivide our VPC, we can do that using what is called a subnet. So S1, S2, and S3. What is that? Okay, S3, sorry. So this is basically a VPC. Of course, we have a lot of ideas to talk about. We've talked about networking 101. We've talked about private IP addresses and public IP addresses. We're going to talk about them again today, of course, and we're going to talk a lot of new concepts like private and public subnets, not IP addresses. Okay, so as we said, a VPC is a logically isolated virtual network within the AWS cloud. So based on our drawing, we have an AWS cloud, which is right here, and a VPC is part of that cloud. It's an isolated area. It's an isolated network. So you can launch whatever resources you need in that AWS. Okay, so in Azure, it's kind of different. Here it says you can deploy your AWS resources inside of a VPC. In Azure, you deploy it inside what is called a resource group. So yeah, that's the difference, like a small difference between two vendors. Of course, you can have control over cloud, your cloud, let's say, where you can have your own virtual network. So where you can have your own virtual network environments, including the selection of IP address range, creation of subnets, and configuring route tables and networking gateways. So let's go and take a look at VPC. Just enter VPC and it's gonna tell you it's an isolated cloud resources. They very ensure that the word isolated, because of course, as we said, cloud is multi-tenancy and you need to isolate your work somehow, some way. So this is how you isolate your work using a VPC or a virtual private cloud. So as you can see here, with every account or every AWS account, you have what's called a default VPC. So let's check the default or my default VPC. So if I have only one VPC and I have 11 subnets, so those are the default VPC. So here you can see it has no name. And as you can see, this is the CIDR. It's 0.16, which is approximately like 60,000, I think, maybe more. I don't know. And as you can see here, it is a default VPC. Of course, everything in it, like the subnets, as you can see here, the CIDR, it's associated. Everything is by default. So best practice, if you want to add something to your VPC, create it on a new one. Don't edit the default VPC. Just create a new VPC with the features that you need. Okay, so key features. Subnetting, which is one. So we're going to talk about subnetting first. Of course, we have a public subnet, private subnet, and isolated subnet. So we have like three kinds. So private, public, and isolated. So I R for private and P for that's P. So R for private and P for public. So what's the difference between these three? Let's start with the public, as it's much easier. So the public, as you can see here, it has internet access, so internet can come right here, and it is connected to the internet, so it has a public IP address range. Private IP address, on the other hand, has like a gateway, like security here. Internet can access through it, not through it directly, but it can use what's called an app gateway and an internet gateway and all these kinds of stuff. So this can be accessible to the internet. Yeah, the public subnets are accessible directly through the internet. These are not directly accessible through the internet. They use like gateways, security guards, and all this kind of stuff. Isolated have no internet access, not directly or directly. They don't have any kind of internet access. Of course, isolated is like for compliance reasons, maybe a bank, maybe stuff like this. So yeah. So the second one, of course, we're gonna talk about is IP addresses. We've talked about IPv4 and IPv6, and we've talked IPv4 is binary, or yeah, binary, and IPv6 is in hexadecimal. We've talked about them. And we can use both if we want to use a VPC. So if we create a VPC, you can see that it has an IPv6 CIDR block and an IPv4 CIDR block. So it has both. And you can customize it, of course. So as I said, if you want to customize your VPC, please don't do it on the default VPC. Use another one. Use a new one. Of course, here, as you can see, I can customize my own CIDR block. So I can, it says here that I have to choose a number between 16 and 28. Um, of course, in networking in general, subnetting, you have to take in consideration the first IP address and the second IP address. The first one is for network host, I guess, like network. It's the first one. So this is like, you can't assign it to any kind of user. This is for the network, and this is for the broadcast. So this is an basic networking. In cloud, it's a bit different. So in cloud, they take up to 5. So 2 for cloud. Yeah, let me write these better. So 1, 2, and 3. So the first one and the second one are the same. They are used for cloud stuff. Like these are used for cloud naming, let's see, or cloud usage. And they come after, 3 of them actually come after the naming. So let me like put it right up here. And this one right up here. Let me just delete it. I don't need it. And the third one is for future usage. So the third one here is for AWS future usage. Okay, so why does it say that I have until 28 to choose from? Because of course, if we said like 28 subnet, how many users or how many IPs, we're gonna see it's 13 usable 13 usable IP addresses. Of course, in cloud, you're gonna like minus 5 out of 16. So it's gonna like be 11, not 13. Okay. So you can like create a VPC. We can like 10.0.0.0 and we can do it like 26, let's say. And that's it. We just create it. So yeah, you can call it VPC1. And that's it. You can create also VPC and more. You can attach like subnets. You can attach route tables. This is like, it's gonna help you a lot. We're gonna talk about it more. So routing, of course, routing is the action of if I have like a subnet and another subnet. So routing is the direction of traffic, maybe the internet traffic, whatever kind of traffic. So this is routing. So the first one is called a route table. Of course, if we like, let me go back to VPC and go down, I can see my route table. Where is it? Here it is. So your VPC subnets and route tables. It is used for controlling traffic between subnets and to the internet. So yeah, route tables, as we said here, control traffic between subnets or maybe through the internet, to the internet, sorry. So internet gateway enables communication between your VPC and the internet. Of course, there's one by default. You don't have to, but if you want to create another VPC, you have to incorporate an internet gateway with. A NAT gateway is you allow an instance in a private subnet to connect to the internet, but prevent the internet from accessing those instances. Okay, so you may understand if we want to do an instance. So let's have an instance right here. So basically, NAT gateway, it says that it gives the ability to, let me do it in green. So it gives the ability to the instance to go to the internet, but nothing comes into it. Okay, based on your ideas, why do we need such a thing? Like, why do we need an instance to be connected to the internet, but not the internet connected to it, or anything to come to it? It's very simple, actually. If you would understand the use cases, you're gonna be like, oh yeah, that makes sense. So basically, if we have like these use cases are typically used for databases. So let's say you need to update this database. So I need to update this database. Patching, stuff like this. Patching, updating, and this kind of stuff. Okay. So of course, database servers should not be connected to the internet, or anyone else will get or will have access to it. So that's not good. So okay, database servers are not connected to the internet, but we need to update that database using the internet. So this is why we use NAT gateways, and this is why we put a database in a private subnet and attach it to a NAT gateway. Does anyone have any kind of question till now? اوكي، بالعربي ارجع اعيد بس بشكل بسيط. في عنا شيء اسمه راوت تيبلز. راوت تيبل بيساعدنا في التحكم في الترافيك، في الداتا ما بين السبنتس واللي جاي من الانترنت. انترنت جيت واي بعطينا انه يخلينا نتصل مع الانترنت ويكون في تواصل. نات جيت واي رح يخلينا في انستنسز ببرايفت نتورك او ببرايفت سبنت اللي ما لها وصول للانترنت يكون لها وصول للانترنت، بس اي شيء من الانترنت ما يشبك عليها. يعني هاي السيرفر هو بيقدر يتواصل مع الانترنت بس ما بيقدر الانترنت يعمل العكس. ليش بنحتاج هذا الاشي؟ طب يعني اوكي منطقيا نحكي انه اوكي هذا الاي سي 2 انستنس اللي فيها داتابيس لا بتقدر تعمل كونكشن على الانترنت بس ما بتقدر يجيها اشي او ينرسل لها اشي. عشان اذا بنحتاج نسوي ابديت لهذا الداتابيس يكون في قدرة انه احنا نسويه بدون ما نعرض هاي الداتابيس للخطر. Okay, so security, we've talked about security groups and network access control lists. So we're going to talk about them again. A quick recap. Let's draw a table. I'm going to change the color blue. I'm tired of it. Okay, so let's have a quick table of subnet or security group, sorry, and network access control list. So the first thing we have said, if you remember, guys, that this is stateful. Like hotel doorman. So it looks into what is coming, but not what is going out. Okay, maybe makes sense, maybe not. And this is the totally opposite. So this is stateless, like the airport police. Oh, sorry, not police doesn't stateless, so it doesn't save the state. So it looks in both that's coming and going out. Of course, there's also different more like differences. Like one takes only allow, one takes allow and deny, like network access control lists. And yeah, so it's like a firewall, and we said the security group is on the instance level. So scope is on instance level, and this is on the subnet level. I'm getting good at drawing, not gonna lie. Okay. So let's go to number 5, connectivity. We have a lot of things. So we have what's called the VPN connection, of course. Like all of you knows what a VPN connection, but just to make sure, if you don't, a VPN connection is this is a user. Where's my user? Let me have my user. Okay, elements. Yeah, let's say this is my user. And this is my, I'm gonna choose this server right here. So a VPN, instead of having this connection that is not secured, a VPN connection creates like, you know, that thing on like jail wall stuff that is like spiky. Yeah, this thing right here. That's not a good photo. Okay, you see this thing right here? Yeah. You see this thing right here? This thing. The spiky thing that's on jail walls. This is the VPN. So this is your connection, and no, I don't want any kind of notification. Thank you. And this is a VPN, and this is your normal connection, so it's gonna secure your connection even more. We have what's called a direct connect. So you have a direct. This is a standalone service actually. So if you want to direct connect, you're gonna have a standalone service that's called the direct connect. We're gonna talk about it later on. So VPC peering. This is one of the most important thing I want to talk about. So VPC peering. So let's say I have two VPC, so V1 and V2. That's V3. I want V2, so guys, I want V2 and V1. And I want them to communicate with each other. The way I do that is called VPC peering. So if I peered 1 to 2, that doesn't mean that 2 is connected to 1. It's not what is called a transient peering. So let's say if I have 3 VPCs, and 1 is connected to 2 and 2 is connected to 3, so this is 1, this is 2, this is 3, that doesn't mean 3 is connected to 1 because 2 is connected to it. No, that's not true. So VPC peerings allow only one-sided communication. It's not what is called transient. So this is thing you really should consider. Of course, if you're a solutions architect, you need to understand this actually came into my exam. It asked me if VPC A is connected to B and B is connected to C, so is C connected to A? Of course, you're gonna say, no, it's not, because it's not a transient process. Okay. The way to solve this is by uploading a server called Transit Gateway. So Transit Gateway. Let me add a text box and call it Transit Gateway. So this Transit Gateway acts like an intermediary between all of them. I removed the VPC by mistake. So this Transit Gateway acts like an intermediary between these 3. And now these 3 are connected. So if we went to Amazon and we clicked or went down here, I think I'm gonna, yes, here it is, a transit gateway, okay? So this is another service, so it can help you manage, even like on-premise, like if you have a house or that's a crooked house, okay. Even if you have a house or an on-premise network, you can connect it to a transit gateway. It helps you like peer multiple VPCs and also on-premise network. Okay. So also we have high availability and fault tolerance. Of course, multi-AZ deployments. One VPC can be deployed on multiple availability zones. Let me fix my VPC. So this is my VPC. I can upload it through multiple AZs. So AZ1, A1, A1, and A2. And inside those availability zones, and I can apply subnets. Okay. And elastic IP addresses. We've talked about elastic IP addresses in the EC2 session. But a quick recap, an elastic IP address is a static IP address, so it's not changeable, like google.com. So if you want to route to google.com, we press like 888 or 48. It's going to go to Google public DNS. So this is like, it's just the beginning of the internet. 8888 is Google's DNS IP address. This is what's called a static IP address. Okay. So components, of course, like we have like 8 components. So we have a VPC, we have a subnet, route tables, internet gateways, NAT gateways and instances, VPC peering, and elastic IPs endpoints. So one quick note about elastic or NAT. We have like NAT instances and gateways. So the one which is used is gateways. Instances are retired, but they're still in the exam. Okay. So this is a quick note. You need to understand that we have both NAT instances and gateways. Gateways are used. Instances are, or NAT instances are retired, but they're still in the exam. So you can't use NAT instances anymore. Okay. So subnets, of course, subnet, we have talked about subnets. It's a part of a VPC. It's what divides a VPC, so it's a subnetwork. And it must reside entirely with one AZ and cannot span zones. So what can span zones is a VPC. What can't span on zones is a subnet, as we draw right here. So you can see here we have the availability 1 and availability 2, and here's the subnets, and the VPC spans over them. Okay, so we have a public subnet, a private subnet, and a CIDR block. So if we know CIDR block for a fact, a public subnet, it has a route to an internet gateway, and this has a subnet without direct route, but it usually typically uses either an internet gateway or a NAT instance. Okay, NAT gateway, sorry. So internet gateway, it looks like this. It looks like the Roman entrance. So if you said like Roman entrance, yeah, 100% it looked like the Roman or the Roman. Look, come on. It looks like this one right here. So guys, yeah, you wanna remember internet gateways? Remember the Romans, الحضارة الرومانية. Okay. So an internet gateway allows communication, it said, about for instances in your VPC and the internet. It's horizontal scales, it is redundant, and it's highly available. Of course, we know all of that. So key features, it has internet access and gives you public IP. So public subnets need public IP addresses. You can think of it of like a router in your own home. So internet gateway, router. So Bastion hosts. Oh, Bastion hosts. I don't know, guys. Do you remember the way I SSH into an instance? And I told you this is the more secure way to enter an instance. If you remember. Okay. There is a way you can enter an instance using a key, which is created out of two keys, a private key and a public key. You can either open it using a PuTTY to SSH into this instance, or you can use what's called an open SSH protocol. So .pem or .ppk. So a Bastion host basically is two instances. Actually, I don't think this is recommended by AWS, but I think it's still in the exam. So let's have two instances. Let's make them smaller. One is private, so let's have a big X on it. And no, I want an X. So this is private, and this is our Bastion host. So a Bastion host is connected to the internet. And if you want to connect through that instance, you have to SSH using a Bastion host to create it. So SSH. This is a Bastion host. So it has the same idea of a NAT gateway. It's not a best practice in AWS, but I think it's still in the exam. So I like to bring it out here. So as you see here, it's known as a jump box as well. It's a special purpose instance that acts as a gateway between a public network and a private network. So we said here, no entrance, yes entrance. and it provides a secure entry point for admin to access instances in a private subnet. And by using it, you can enhance security by limiting direct access. So this instance right here only has access to this Bastion server right here and nothing else. So nothing can go in or go out of the instance except to that Bastion server. So this is a good security measure. SSH, we've talked about keys, and you have the responsibility of securing your keys. Okay. So does anyone have any kind of question on the Bastion host? Okay. So NAT gateway, these components allow instances in a private subnet to connect to the internet or to another AWS resources, but prevent the internet from initiating connection with these instances. So go back to this drawing. This one, this is what NAT instances and gateway does. Okay. So key features, we have what's called NAT instances, which is an instance configured to do NAT functionalities, and a NAT gateway, of course, we said this is retired. You can't use this anymore. You only have to use a gateway. So this is more efficient and more reliable and easier to manage than instances. So use cases. You can host like use cases for VPC. You can make it for hosting a web application, hybrid cloud architectures. If you remember transit gateways, data analysis, disaster recovery, because VPC is multi-AZ and can span into a lot of AZs. So let's go to best practices. Design for high availability. You need to use multiple availability zones to ensure redundancy. And segment your network. We've talked about segmenting our network to make it easier to manage and to make it more secure. Security first, so we have to use security groups and network access control list and audit and review these security configurations. So logs, we've talked about logs, it's CloudTrail, and monitor metrics, alarms, CloudWatch. Okay, guys, so does anyone have any kind of questions before we go and take a look to the console? So we're going to take a quick look onto the console. Okay. So if we went back to our VPC and we want to create a VPC, we can only create a VPC and VPC only. And we can create, as you can see here, we can create a public and two private VPCs. And you can see here network connection. So this is going to help you a lot. So here you can auto-generate. It's going to help you with all the defaults. So here you can see number of availability zones. It's going to create it over 2 availability zones. Number of public subnets and private subnets 2 and 2, as you can see here. So 2 public and 2 private. NAT gateways, we don't have any kind of NAT gateways. We have S3 gateway, and you can see here you can have DNS options. So that's very awesome. Of course, as you can see here, based on the network, we have public network that is connected. You can see here the way it's connected. So the public connections are connected through one route table or one route rule, and the private are connected through 1 and 2. So this is great, actually. I can just launch this and it can go and create, but I think it's gonna charge me. But let's do it anyway. So here you can see it's creating all these kind of stuff. Here you can see associated route tables. It's very easy to create a VPC in the cloud. It's very easy. As you can see here, so it's just created like 4 subnets, 4 route tables, and 2 network connections. Here you can see a project internet gateway. It's very easy, like, oof, that's created. So let me just delete it before it starts charging me. Let's go on this. Delete VPC. Yes, I want to delete everything. Of course, the default VPC doesn't cost you anything, but creating new internet gateways and new VPCs, VPC itself, it doesn't cost you anything, but the association of internet gateways and NAT gateways, those will cost you. Okay, guys, so I think that's it for today's session. What is the difference between Amazon Connect and Amazon Direct Connect? Okay, so let me check Amazon Connect because I don't think there's yeah, Amazon Connect. So it's this is an automatic calling service. This is like a call center. Okay, AWS Connect is a calling service, like a call center. You can. And Direct Connect is totally different. Direct Connect is like it's literally they hook you up with a fiber optic cable that you attach directly from your on-premise network to your closest AWS region or AWS data center. So those are two different things. I think AWS Connect allows you to integrate with Lex, which is Lexa, as you all know, and you can have chatbots, call chatbots. Yeah. Okay, guys, so let me stop the recording. Here you go. Stop the recording.